All right, so we're going to look a little bit at statistics, statistical questions, and types of data. This is kind of just like an introduction to some of the main terms in statistics, and especially relating that to this idea of what is a statistical question. Okay, so statistics, we could define that as the collecting, analyzing, and presenting of data. So whether you're gathering that data, whether you're looking at it, trying to interpret it, make sense of it, or whether you're sharing it with people, that's all part of statistics. And we do that all the time. Statistical question is a question we would use to collect data. And our definition is that we would say a question that can be answered with data and which has variability. So variability then would be something we need to define. And variability has to do with how spread out or different a set of data is. And so if you have data that's all the same versus if you're getting lots of different things. And the statistical question should have variability. So let's look at some examples. Think about, are these statistical questions or not, and how does this term variability make sense? So if we had this question, what color is my cat Alfred's fur? There she is. And black and white, black and white, black and white, black and white. If we asked 4 people, we would get the exact same 4 answers. And so what we would go is we would go back to this idea of variability, in that there's no variability in the answers. They're not different. It's not spread out. It's all the same thing. So then we would say that this right here is not a statistical question because there is no variability in the answers. If I ask a different question, like how many cats do the students in my class have, and let's say we asked 4 different people, we might get 4 different answers, 0, 2, 1, 0 from those 4 people. That this term variability now is true. We see different types of answers, so we would say, yes, this is a statistical question. How many cats do the students in my class have? So let's look at a couple others. Here's 2. So you can think about those for a second. How tall are the players on the basketball team? And what is Bob's favorite flavor of ice cream? And if we were to ask multiple people, or if we were to collect that data, we want to think about, would we get variability or not? And so for that first one, absolutely yes. How tall are the players of the basketball team? We could measure them all. We'd get a huge range of measurements, and so we would have different data. That is a statistical question. Asking what Bob's favorite flavor of ice cream is, there's just one answer. There's no variability. We could talk to numerous people and get it from numerous people, but it's the same thing. Okay. Now we could take that question, what is Bob's favorite flavor of ice cream, and this topic of favorite ice cream flavor, we could turn that into a statistical question. So for example, if I said, what are the students' favorite flavors of ice cream, and I asked everyone in my class, I'd get chocolate, vanilla, strawberry, lots of different answers, lots of variability. And so yes, that would be a statistical question. If we looked at this last one, what scores did students get on the Unit 5 test? Again, we would get lots of different answers. Yes, variability. Yes, it is a statistical question. So when you're given that question and you're asked, is this statistical or not, the key thing to really look for is there going to be variability in the answer. And if there's not, you might want to think about, okay, if I want to try to gather data, how could I rework that question? Okay. And then when you're looking at the data, there's also sort of 2 main types of data, and then of those 2 main types, there's sort of subtypes. We could have qualitative data and quantitative data. Qualitative data is data that consists of words and categories. Sometimes it's even called categorical data. And then quantitative data is data that consists of numbers. So if you collect your data and you're getting numbers as answers, we call that quantitative data. So if we even just think about some of these questions up here, we can start thinking about that. Now, within quantitative, we also have 2 different types of quantitative data. The first is discrete quantitative data, which is numerical data which can only take certain values, and the other is continuous quantitative data. Those are data that can take any value over a range. So when we think of this term discrete or certain values, that means there's only specific numbers that you could get as an answer. When we say continuous, we mean you could have a whole bunch of different answers over a range of reasonable things. So let's look at these questions up here and further clarify for the statistical questions, is it qualitative, discrete quantitative, or continuous quantitative? So if we look at this first one up here, where we have how many cats does the students in my class have, we can see we have numbers as our data, which means that it's going to be one of the 2 types of quantitative, and then it's going to have to be discrete, because it can only take certain values. You couldn't have 0.5 or 0.8 or 2.32. You're just going to have whole numbers in this situation. So there's discrete quantitative data. Then if we look at this next one up here, how tall are the players on the basketball team? If we were to collect that data, we would get numbers, so it's going to be quantitative. And then if we think about the numbers, are they going to be specific, or could it be anything over a range? And since you can have a whole range, you could have 2.2 meters, you could have 3, or you could do inches, like you could have decimals, fractions, a whole range of data. But there's going to be a range of where it starts and where it ends. So we would say that that is continuous quantitative data. But what are the students' favorite flavors of ice cream? We're not going to get numbers in that. So we're going to put that as qualitative data. It's going to be words or categories, so chocolate, vanilla, something. And that's really going to help you determine what kind of graph you're going to do, whether it's, usually you're going to be doing sort of like a bar graph if you're dealing with quantitative data or qualitative data. And then the last one, what score did students get on the Unit 5 test? Again, you're going to get numbers, and you're going to be getting discrete quantitative data because there's only specific scores that they can have. You can't have anything between, if you have a 10 question test, you can't have 2.38 points on that and 2.39 points. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Maybe half points, but then still that's limiting your set of data. So that's the main information with statistics. What it is, what a statistical question looks like, how you can tell if it's a statistical question because of that variability, and then when you look at that data, what are the different types of data that you could have.